All right, so this lesson is on piecewise functions. Piecewise functions are just functions that have restrictive domains, and you have two or more functions put into the same equation, or two or more. You can think of them as formulas. So let's take a look at this. It says a piecewise function is a function in which more than one formula or equation is used to define the output. Each formula or function has its own domain, and the domain is the union of all of these smaller domains. So we write a piecewise function like this. So f of x equals formula 1, meaning the first equation with a restricted domain, formula 2 with a restricted domain, formula 3, and so on. So for our first function, we have f of x equals 5x minus 3 for all x values that are less than, negative 2. We also have the function x plus 8 for all x values that are less than or equal to, for all x values such that negative 2 is less than or equal to x is less than 3. And lastly, the function 1/3 x plus 7 for all x values that are greater than or equal to 3. So the first thing that I want to remind you of is when you have a less than symbol, remember that you're going to have an open circle. Less than or equal to means the circle is going to be closed. Less than, open circle, greater than or equal to, closed circle. So that's going to help us when we graph our functions. So the first thing that we're going to do is we're going to evaluate our function. And we're going to evaluate our function over these given domains. So we're going to evaluate the first function at f of 2. So you want to look at the domain values and see where does 2 fall into your domain restriction, and that's the function that you're going to evaluate. So this is a positive 2. Well, positive 2 does not fall into the domain restriction, all values of x less than negative 2. Positive 2 falls into the domain restriction of negative 2 is less than or equal to x is less than 3. So we're evaluating this function right here, meaning that we're going to plug in 2 for this x value. So f of 2 equals 2 plus 8. So f of 2 equals 10. Let's look at our next one. Our next function wants us to evaluate f of 4. We're evaluating f of negative 4. So we need to figure out what function has a domain restriction for x at negative 4. Well, that's all x values that are less than 2. So that means I'm evaluating this function. 5x minus 3. So f of negative 4 equals 5 times negative 4 minus 3. 5 times negative 4 is negative 20, minus 3 is negative 23. So f of negative 4 equals negative 23. So let's take a look at our next function. We're evaluating f of positive 3. So we have to figure out where positive 3 lies in our domain. So when x is positive 3, we're using this domain, x is greater than or equal to positive 3. So we're going to evaluate using this function. So f of 3 equals 1/3 times 3 plus 7. Well, 1/3 of 3 is 1, and 1 plus 7 is 8. So f of positive 3 equals 8. Our last function that we need to evaluate has a domain value of 0. So what function has a domain that includes 0? Well, this first function is all numbers that are less than -2. The second function is all numbers that fall in between -2 and 3, including -2, and 0 lives right here. So we're evaluating this function for f of 0. So f of 0 equals 0 plus 8. Remember, we're just replacing the x value with the number we're evaluating. Well, 0 plus 8 is 8, so f of 0 equals 8. All right, so now we're going to look at the y-intercepts. So it says the three linear equations have y-intercepts of -3, 8, and 7 respectively. And we know that from the functions. This is your y-intercept, y equals mx plus b. So this has a y-intercept of -3, this has a y-intercept of positive 8, and this has a y-intercept of positive 7. Yet a function can have only one y-intercept. Which of these is the y-intercept of this function? Well, you have to remember what a y-intercept means. So the y-intercept is where you cross the y-axis. And remember, this happens when x equals 0. So now we're going to look at the domain. Which domain allows for an input of 0? Well, remember, we already evaluated these functions, and the domain, or the x input 0, is going to live in between -2 and positive 3. So the only function, or the function with the y-intercept, is going to be this function right here. So the true y-intercept is 8. All right. So now let's look at our next question. It says calculate the average rate of change. So we've done several warm-ups on average rate of change. Remember that the average rate of change is talking about slope. Average rate of change is just another way to say slope. So we have to calculate the average rate of change over the interval -3 to positive 9. Well, that just means we're evaluating f of -3, and then we're evaluating f of 9, and we're going to find the rate of change, the change in the y over the change in the x. That's what our slope is. So when x is -3, I am going to use the function 5x minus 3. Why? Because my input, -3, falls in this domain. All x values that are less than -2. When x is 9, I'm going to evaluate using this function. Why? Because our domain represents all x values that are greater than or equal to 3. So f of -3 is going to be evaluated over the function 5x minus 3, and f of 9 is going to be evaluated over the function 1/3 x plus 7. So let's go ahead and evaluate those functions. So when I let x equal -3, I have 5 times -3 minus 3, which is 15 minus, sorry, it's a -15 minus 3, which is -18. So x and f of x. I'm going to make a little table here. When my input is -3, my output is -18. Let's evaluate the second part of our domain interval, which is +9. So when x is +9, I have 1/3 times 9 plus 7. Well, 1/3 of 9 is 3, plus 7 is 10. So when I let x equal 9, my output is 10. So now we're going to calculate the slope because average rate of change is slope. Remember, we want our change in y. Well, from -18 to +10, that is 28 over our change in x. -3 to +9 is 12. So our average rate of change is 28 over 12. And I can divide both of those by 4. So our average rate of change equals 7/3. Question number 2 asks us to graph the function, determine the range of each function, and then asks us if this graph is continuous or discontinuous. So let's talk about the graphs. So I know that this function is going to have a y-intercept of 4 because it's x plus 4. So it's like y equals x plus 4. So my y-intercept is 4, and my slope, remember slope, is the number that's attached to the x value. So that's going to equal 1. In my second equation, y equals -3/2 x plus 9. So my y-intercept is 9, and my slope is -3/2. So the first thing that I'm going to do is I'm going to graph those two equations. I'm going to graph those two equations, and then we'll worry about the domain. So for example, or for the first function, g of x equals x plus 4, I begin at +4 on the y-axis, and I have a slope of 1, meaning I go up 1 and to the right 1, up 1 and to the right 1. I can also, from the y-intercept, go in the opposite direction, down 1 and to the left 1, down 1 and to the left 1. And I am going to connect all of these points with a nice straight line. Again, we'll adjust it by looking at the domain after we graph both of our functions. We'll adjust our domains after we graph our functions. So my second function has a y-intercept of +9. So I begin on the y-axis at +9, 4, 5, 6, 7, 8, +9. And this has a slope of -3/2, meaning I go down 1, 2, 3, to the right 1, 2. Down 1, 2, 3, to the right 1, 2. Down 1, 2, 3, to the right 1, 2. So now I'm going to go ahead and graph this line. And I am now going to go back to each function, and I'm going to look at the domain restrictions, meaning the input values. Okay? So for our first function, g of x equals x plus 4, this is only true when -2 is less than or equal to x is less than or equal to +2. So I'm going to have a closed circle on -2 and a closed circle on the +2. So when x is -2, -1, -2. This is going to get a closed circle. And when x is +2, closed circle. So this function only runs from -2 to +2. So I need to erase or get rid of everything else. Nothing else is included in that function. Remember, it just runs from -2 to +2. My second function, g of x, equals -3/2 x plus 9. So this function has a domain that runs from +2 to +6. +2 is not included, open circle. +6 is included. All right. So when I look at my red line, I see that I'm going to have an open circle at the +2. And you'll notice that the +2 is actually covered by the purple circle. So we're going to leave that. And then it runs to +6. 2, 4, 6. So everything else before +2 and after +6 gets erased. So there's my graph of the function. So determine the range of the function. Remember that the range is your output values. What's the highest that your graph goes, and what's the lowest that your graph goes? Well, we write our range in order from smallest to largest. So the lowest y value is 0, and it's got a closed circle on the 0. So that means it's included, is less than or equal to y, because range is a y value. And there's a closed circle on the +1, 2, 3, 4. So less than or equal to +4. So your range, the range for this function, it's actually not 0. It is 0. It's not +4. Sorry. This is +1, 2, 3, 4, 5, 6. So your range is from 0 to 6. So 0 is less than or equal to y is less than or equal to 6. Is this graph continuous or discontinuous? Continuous means that it goes on forever with no openings, no holes, right? Discontinuous would be something that has a hole in it. For example, if I were to give you a graph like this, this is discontinuous. And it's discontinuous because at -1, if you look at the blue graph, at -1, both functions, the quadratic function and the horizontal line, neither one of those have a closed circle at -1. Our graph is continuous. All right, so let's take a look at your homework. So your homework for today is going to be this worksheet. This worksheet is page 28 out of your packet. So for the first part, you're just matching the piecewise functions to the graph. I suggest that you take a really good look at the domain restrictions on each one of them. They're all linear functions, so you don't have to identify them as being absolute value or quadratic. So you're just going to determine based off of y-intercepts. You're going to determine which functions match which graph based off of y-intercepts and domain restrictions. So I'll do the first one with you. So I'm looking for a function that has a y-intercept of -4 and a slope of 1. Well, a y-intercept of -4, that's not this. That's not this. That is not this function. That is not this function. It could be this function. This crosses the y-axis at -4. And it's not this function. So without looking any further, I know that number 1 matches graph E, but I just want to make sure. I want to prove it, right? So I know that the piecewise function for number 1 has a domain restriction x is less than or equal to 1 for all f of x equals x minus 4. So I cross at +4. I have a slope of 1, and this is for all x that are less than or equal to 1. Well, that matches. That's true. So now let's see if the second part of my graph has the function f of x equals 3x for all x values that are greater than 1. So that means I need to have an open circle on +1, and this has a slope of up 3 over 1. Up 3 over 1. So E is in fact the match for number 1. So your homework, again, your practice, technically not due till Tuesday. That's when you take your test. However, it'd be good for you to have this done on Monday, so when you take a look at the answers, you can ask questions on things that you missed.